Hello viewers, I'm going to be showing you how to solve this using binomial theory. Of course, if you look at this question, we have evaluate 1.03. Because this question is not given in this format. It is not given in this format. Okay, so we have to convert this question to this format before we can apply binomial theorem in solving it. So let's do it. If I say 1.03, okay, all raised to power 3 equal to, if I decide to say 1 plus 0.03 all raised to power 3, yes, this is true, because if I say 1 plus 0.03, it will give me 1.03. So if you look at it, I've been able to convert from this format to this format, and so we can now do a comparison. And a plus b all raised to power n equal to 1 plus 0.03 all raised to the power of 3. So we can now say that this is our a, this is our b, and of course this is our n. And so whenever you're given, if you're given something of this nature, maybe 1.998, maybe raised to power 2, or whichever way, let's say 1.98 raised power 2. So you look for a way in which you can convert this to this form. Because if, for instance, you say 2 minus 0.02 raised power 2, this will give you exactly this. If you say, if you use your calculator to punch 2 minus 0.02, it will give you 1.98. So that means you've converted it to this form, and then you can solve. Let's check 2 minus 0.02. That will give you 1.98 is correct. Or you can also say 1 plus 0.98. Yeah. So if you don't want to do it this way, you can say 1 plus 0.98 all raised to power 2 will still give you this. So the backdrop is you are able to convert the decimal into this form such that your a is this, your b is this, and your n is this. The same thing applies here. Note you are going to have plus here, so that your a will be this, your b will be negative 0.02, and then your n will be this. So basically, if you're given a question of this nature and you're asked to use binomial theorem, you convert it first to this form before you start solving. Okay, let's solve this. And so given this, we have to express this again. We are asked to expand this up to the power of 3. So let me express this so that, because that's the formula we are going to be using in solving it. So a plus b all raised to the power of n in binomial theorem can also be expressed as a raised by n plus n a raised by n minus 1 b raised by 1 plus n into n minus 1 all over 2 factorial a all over 2 factorial a raised by n minus 2 b raised by 2 plus, okay, I think, let me see if I can, okay, plus n, okay, let me write it again so that I can capture it up to 3. So this can be expressed a plus b all raised by n can be expressed as a raised by n plus na raised by n minus 1 b raised by 1 plus n into n minus 1 all over 2 factorial a raised by n minus 1 and minus 2b raised by 2 plus n into n minus 1 into n minus 2 all over 3 factorial a raised by n minus 3 b raised by 3. So basically this is how to expand it, plus depending on the number of terms you are asked to expand it to, so you keep on expanding it, because this one we're asked to expand it up until the third term raised by 3, so we stop here. But if you're asked to expand it up to 4, you continue the expansion, because you're going to be making use of this formula to solve this problem. So since we are asked to stop at 3, we stop here. But if you're asked to stop at 4, you continue the expansion. 5, you continue the expansion down to 5. So in this case, let's continue our solving. So we know that our a from this point now, a equal to 1, our b is 0.03, and our n is 3. So let's solve it. A is 1, n is 3 raised by 3, plus n is 3 into a is 1 raised by n, which is 3 minus 1, times b is what? 0.03 all raised to the power of 1. So we have plus. We are done with this part now. So we now consider this part down here. So this will give you, what is our n is 3 into our n is still 3, because from here 3 minus 1 all over 2 factorial is the same thing as saying 2 times 1. Then we have a is 1, this is a is 1 here, raised by 3 minus 2 dot, which is the same thing as multiplication. Okay, we can put this in brackets, dot, b is 0.03 all raised to the power of 2. And then we have plus. So the next one is n, which is 3, into our n is still 3 minus 1, another 3 minus 2, all over 3 factorial is the same thing as saying 3 times 2 times 1, and our a is 1 raised to the power of n is 3 minus 3, and our b, we can put this in brackets, and our b is 0.03 all raised to the power of 3. Okay, and so far so good. We are going. Okay, so from here we have a to b. 1 raised by 3 is the same thing as 1, plus 1 raised by 3 minus 1 is 1 raised by 2, and 1 raised by 2 is the same thing as 1. So this will be 3 into 1 into 0.03 raised by 1 is the same thing as 0.03. So we are done with this now. So we have plus. So we'll now consider up to this point. Okay, now this is 3. 3 minus 1 is 2. So 3 into 2 into, we consider this. 1 raised by 3 minus 2 is the same is 1 raised by 1, which is 1. And multiplying 0.03 raised by 2. 0.03 raised by 2. That will give us 0.0009. So this is 0.0009 divided by 2 times 1 here. 2 times 1 here is 2, plus, okay, here we have 3, which is this. 3 minus 1 is 2. 3 here minus 2 here is 1, divided by 3 times 2 times 1 will give us 6, into 1 raised by 3 minus 3 is 1 raised by 0, and any number raised by 0 is 1, and then times 0.03 raised by 3, so we have 0.03 raised to the power of 3. That will give us 0.123427. That's what we have. So at this point, this can cancel this. This is 6. 3 times 2 here is 6, so it's out. So we are left with 1 plus 3 times 0.03, 3 times 3 times 0.03. That will give us 0.09. So the whole of this now will be 0.09 plus 3 times 0.009. So we have 3 times 0.0009. That will give us 0.0027. We are done with this now. And so we are considering this now. So this will be, okay, this is 1. So 1 times 1 times 1 times this will give us the same plus 0.123427. So we are going to add everything here. So we have 1 plus 0.09 plus 0.0027 plus 0.000027 equal to, so this will be equal to 1.092727. So that is our answer. So we have 1.092727. Now, what does this imply? This means that if you use your calculator, for instance, to check the value of 1.03 all raised to the power of 3, it will give you this answer. So this is what it implies. So when you are done solving it this way, you can now punch your calculator, bracket open 1.03 raised to power 3, and see if you have the same answer as this. So viewers, basically this is how to evaluate a problem of this nature using binomial expansion. Thank you.